So here we're still going to be looking at linear patterns, but we're going to go about it from kind of the back to front way that we've been looking at things. So in this case, instead of trying to find out what the rule is, I'm going to give you the rule, and you've got to work backwards to actually graph the rule. Now, there's a few ways you can go about doing this, but for right now we're going to use the table to help link us from the rule to the graph. So, looking at an example problem, the cost per hour to rent a bicycle in New York City is $10 per hour. So for every hour you have to pay $10 for it, plus you have to pay $5 for a helmet, and that's just up front. So you could ride your bike for 40 hours and they'd still just charge you $5 once for the helmet that you've rented. And you must pay for the full hour, so what they're saying is that even if you're only going to go for a half an hour bike ride, they're still going to charge you for the full hour, so they'll round you up to every full hour. So again, if you went for like an hour and 15 minutes, they'd charge you for 2 hours because you were there for a whole 1 hour and then an additional part of the next hour. So if we look at how to write out this rule, where they're getting it from, is this idea that $10 per hour, where do you see 10 in the rule? You see it right there. Well, what do you think the H stands for? Well, you might be thinking that stands for hours. And here we're looking at that as $10 for every hour. So if you go 10 times 1 for the first hour, or for 1 hour, you'd get $10. If you rented it for 4 hours, you could go 10 times 4 and you'd get 40. So that's what the H comes from. That's 10 times H, or 10 times every hour that you rent the bike. What's the plus 5? This is for the helmet. We notice that that's not times for every hour, that's just the additional thing that gets added on. So we go 10 times the number of hours that you've ridden, or will ride, plus the $5 for the helmet. That's basically how that rule is describing the problem to us in mathematical language here. Exactly what we've said. They're going to charge us $10 for every hour, plus $5 for a helmet, and that's going to be my total cost. So, if we're going to write a table, there's two things that we need to put into it, because we always need the two variables. One is going to be the cost, and one is going to be the number of hours. Now it's really tricky here to get this in the wrong order. Really easy to get it in the wrong order. Because as a rule, we generally write the equations as the total of something is equal to the parts of things. And how we put it into the table is actually the opposite way around. So if my rule says C is equal to 10H plus 5, I want you to think really carefully about swapping those locations. So what it equals to goes into the second column, and what you're timesing by goes into the first column. So we'll have H, or hours, and we'll have C, or cost. And so that's what I mean by watch out to get the columns labeled correctly. What you're equal to is always going to be on the left-hand side of the column. Okay, so now that we know that hours are going to go down the right, so what's in it, what are we timesing by every single time, like the pattern number here, goes onto the left-hand side of the equation, the left-hand side of the table, and what you're equal to goes onto the right-hand side, or what comes out. So this is our input side if you want, and if we would decide to just fill it in with a few hour options, we can get some information for ourselves. So for 1 hour, so if H is equal to 1, what's the cost going to be? Well, you could think about it. It's $10 times the 1 hour plus $5, which is equal to 15. And for the next one, for 2 hours, we could say that it's going to be $10 times the 2 hours plus the $5, and that's equal to 25. For 3 hours, it's again 10 times 3 hours plus 5 is equal to 35. For 4 hours, we would have 10 times 4 hours plus 5 is equal to 45. And the last one here, 10 times 5 hours plus 5 would indeed get us 55. So they're actually asking for us to go up to a total of 6 hours. You'll notice here if you read the problem carefully. Make a graph to show the cost of hiring a bike and helmet for up to 6 hours. So we'll add one more here. 6. 10 times 6 plus 5 is equal to 65. So again, I'm actually using the rule, just like they've told me here. The cost is going to be equal to 10 times the number of hours plus 5. So each time I have a new number of hours, such as 1, I go 10 times the 1 plus 5. And then the same for the next one, 2. So I'm going to do 10 times the 2 plus 5. And that's how we're getting that information. It's actually using the rule to generate the values. So these ones over here on the left hand side you actually pick. And on the right hand side you calculate these using the rule. And this is what we call substitution. So if you look carefully, the only thing that we change the entire time is the number of hours. Everything else there stays the same. It's always 10 times 1 plus 5, 10 times something plus 5, 10 times something plus 5. And that's exactly what you see here, 10 times something plus 5. Going on and on and on again. So that's what we mean by substitution. I'm replacing the h, the hours, with the number that I'm actually looking for. So in this case, 5 hours, I replace the h with a 5. Now we've got the table filled out, we need to go ahead and put this onto the graph. So remember that every single point needs to have pairs. So if I want to think about this, I know that I've got my hours and I've got my total costs. So those are the two things that I need to put together somehow on the graph. And they've already labeled it here for you, but you'll notice that hours is along, if you want to think about it as the x-axis, the bottom axis, and cost is up along the y-axis. So just like we've done before, you could kind of imagine that this first column is the x column and the second column is the y column, and make coordinate points such as 1 and 15 or 2 and 25 and put them onto the graph. So for the first number of hours, for 1 hour, I'm going to pay $15. And how am I going up this axis? Let's see. 1, 2, 3, 4. No, that doesn't work, so let's try something else. How about 5, 10, 15, 20? It does work. So we're going to go up in 5s here, 10, 15, and 20. So for the first hour, 1 hour, I'm going to be charged $15. For 2 hours, I'm going to be charged $25. For 3 hours, I'm going to be charged $35. For 4 hours, it's going to be $45. 5 hours is $55. And 6 hours is going to be $65. So from the rule, C is equal to 10h plus 5. I recognize that that was 10 times the number of hours plus 5. And I was able to then make a table with the hours going down the left-hand side and calculate what the cost was going to be for each hour, and then put those points together onto the line. So that's exactly how we go about linking the rule to the graph or to the table. So in the previous problems you've been given the table and you have to find the rule. Here we're working backwards to actually use the rule to make the table, and then we can plot the graph. So again, that's 10 times the number of hours plus $5 for the helmet. And we see we go up in basically a straight line here. And again, between each point we're actually going up by 10, which is what we expect because it's $10 extra for every hour.